Good morning, everybody. Once again, I am here with you for the new session that is related with the solid state physics, paper number 13A. Myself again, Dr. S.D. Chauhan, Department of Physics, Adarsh College, Hingoli. In previous session, we have seen a little bit part related with the crystal structure. Now, as far as the fundamental things, we have seen what exactly the crystal lattice, again the translation vector, what is mean by the unit cell, and what is mean by the basis that we have seen. Now moving forward, today we will see what exactly meaning to be as in symmetry operations are to be there. To understand these symmetry operations, simply we must know that exactly what is the transformation. It's simply any crystal. Sometimes we looks likes to be as in a circular fashion. Sometimes it looks likes to be as in cubic fashion. Sometimes we see some sort of symmetries to be there. Now this symmetry operation exactly somewhere it is rotated around some point or lattice points are to be there, and what exactly it is having the that particular crystal is showing a transformation itself is nothing but to be your symmetry operation is to be there. So there are four types of the symmetry operations are to be there. First one is this translation, second one rotation, third one is reflection, and the fourth one is inversion. No doubt, as far as the lattice are going to be concerned, we are aware about that there are two-dimensional and the three-dimensional lattices are there. And these symmetry operations are also, as far as the translation, rotation and reflection symmetry is to be there. These operations or the symmetry operations are already we can see in the your two-dimensional lattice. But as far as the three-dimensional lattice are going to be concerned, the inversion is the only one which is going to be present, or all other are present, but the inversion needs for that the three-dimensional lattice should be there. In the two-dimensional lattice, the inversion symmetry operations never found. So as far as the first symmetry operation, that is the translation, is going to be concerned, we already discussed in detail what exactly meaning to be as an translation, and related to that how the translation vector works, what type of the translation vectors are there. In the same way, this translation comes as an your symmetry operation. As in the previous session we have seen that translation vector is nothing but to be the whatever be the your space lattice is going to be their form, that is having to be identical surrounding points, that is r dash, which is going to be formed due to the r. That means r dash point or the atom is going to be formed with the r plus what type of the translation is going to be there, that means to be as in t is to be there. That means if you look at this case where we have seen in detail that this r dash is going to be formed with the r plus t is going to be there, and in the three-dimensional case we have seen this r plus n1a plus n2b plus n3c is to be there, as the three vectors are to be there, this along the x-axis, y-axis and z-axis is to be there. This translation vector is for the three-dimensional lattice is going to be concerned, and for the two-dimensional only two vectors are there, that is a and b should be there. And what exactly these translation vectors are, when the translation is going to be, or the translation vector is with the your, or the symmetry operation is with the particularly are having this such type of the translation factor is also to be there. And in this case, as far as the whatever be the translation vectors types are to be there, that is inverting, sorry, as in primitive and the non-primitive translation vectors are to be there, that is to be, we have seen in also detail that with the coefficient containing, if the translation is containing the coefficients of the your integral coefficients are going to be used, that time it gives you the primitive translation. As far as the non-integral coefficients are going to be used in that translation vector, then that type of the translation is nothing but to be non-primitive translation is to be there. So the same thing is going to be occurring here as far as the symmetry operations are going to be concerned. So we will already discuss this part in detail. So moving forward, the second, that is to be as an your rotation symmetry is going to be there, the symmetry operation is going to be concerned. Now in this case, no doubt rotation we can say always around one point, and in the lattice when the rotation is surrounding one point, that is if the rotation by an particular angle, as far as the circle is going to be concerned, it giving you 360 degree, and when the rotation is in the particular theta angle, that may be 60, 90, 180 likewise, and that type of the rotation surrounding one particular point or lattice point, it is nothing but to be rotation symmetry. As far as these type of the symmetry operations are going to be concerned, in the simple way we can found how many number of rotations are available, that is depending with this formula given to be as an n theta is equal to your basically n theta is equal to 2 pi is to be there. Now 2 pi is nothing but to be the angle, that is to be as in pi 180, that into 2, that means to be 360. As far as the circle is going to be concerned, it is to be as in having the angle 360 is to be there. And n theta, the theta, if I want to find out how many folds of operations are possible, according to that theta is going to be there. If suppose one fold, if n value is to be having 1, the value definitely theta value will become 360 or 2 pi is to be there. If this n is having the value, integer value is having to be as an 2, in that case the theta will become definitely 180, and in that case two folds of operations are to be there. And n is nothing but to be showing you simply what type folds of operations are going to be possible. As far as the if you see here the example, it is shown here to be as an 7 number is just for taken as an atoms positions are to be there. And if you look at in this case, here it is to be as an theta angle is nothing but to be 60. So as far as the values are going to be changing for the n, that according to that this theta is going to be changing, and that much amount of folds of operations are going to be there. As far as this example is going to be concerned, here you will see these are the atoms positions shown here at as likewise as n 6 is going to be there. And if n is going to be the 6, if I am putting, then the theta will become definitely as an 60, because 360 by 6 is going to be a 60, you will give, it will give you 60, and that's why the angle and will be as an 60, and that's what here shown in this diagram, that is the 60 degree. And n is nothing but to be become as an 6, that means 6 folds of operations surrounding this O point is going to be there, and that is what the n folds of operations are nothing but to be 6. That means the n is representing how many number of folds of operations are going to be present in that symmetry. No doubt all the whatever be the symmetry rotation operation is to be there, that amount of angle is going to be rotating surrounding that particular point, and such type of the rotation is not, such type of the your operation is nothing but to be symmetry operation is nothing but to be your rotation symmetry is going representing the rotation symmetry. Now again, the very much important factor in this case, whatever the number you want you can put, it is not like that. It is having certain limitations, and what exactly these limitations are going to be there, that is quite interesting. That if n is having the, if you look at these cases, our possible number of cases are nothing but to be here shown, that is n is equal to 1, 2, 3, 4 and 6. The 5 is absent there. The 5 is absent, it is not meaning to be as in missing. It is not possible that 5 folds of operations are to be there. That meaning is to be there. Why this fifth number or the 5-fold operation n is not having to be the value, or why these 5-fold operations are not possible? For that, to understand in detail, we have to see a little bit in detail what exactly this rotation works to be. And to understand that, we have to take into account one example, that if suppose, here is that example. If now in this case, if you look at this diagram, simply here in this case, as far as this is one type of the rotation or the translation is going to be there. If you look at, there are 4 points, that is A, B, C, D. Now A, B, B, C and C, D. This is all are nothing but to be a one type of the translation vector is moving in the along the x-axis. Now this is what the case where I am talking about this translation is going to be there. If I am talking about the AB, BC and the CD are going to be the similar way, next E will be, you will find same at the same distance. That means the translation is going to be fixed. At this amount of distance, the atoms are coming certain repeatedly, periodically, continuously. So this is what the translation as far as this diagram is going to be concerned. Now in this case, what is going to be happening? Suppose this pencil what I have in my hand, this is suppose the distance is BC. Now in this case, what I am doing now, keep in your mind, we are finding out why there is no possibility of 5-fold operations are to be there. So for this case, now if suppose this BC is supposed to be, this one is the your translation, here it is shown in this case also. And if I am this BC translation, either it is going to be continuously in this direction, it is okay. But now what I am doing at this stage, when I am coming at the B point or BC point, so at this B point I am doing the translation reverse, that is anti-clockwise, and I will found the new point, that is B will become to be as an, or B will give me the new point, that is to be B dash. If you look at this case, if I am using the anti-clockwise rotation, not as in regular, at the B stage what I am doing, I am using the anti-clockwise rotation, and that will give me the point B dash. And at this stage, in the same way, from the C I am giving you the clockwise direction rotation, and at this point, at this stage I will found the another point that is called to be as in C dash here. So at the B point what I am doing, I am doing the anti-clockwise rotation, or at the C point I am doing the clockwise rotation, and I am getting the two new points that are called as a B dash and the C dash are there. No doubt this translation what we found, that is BC what B dash C dash what we found, it is the part of your regular transmission, that is BC is going to be there. So to find out this what exactly correlated with BC and B dash C dash is to be there, although it is the magnitude or multiples of the whatever be the B dash C dash newly formed vector or newly formed line are the part of, or whatever be the your multiples of the BC original vector, original your translation is to be there. Now I am using this vector word as a translation because this is going to be continuous, that's why it is called to be as a translation is to be there. Now in this case here, if I want to find out, correlate these particular things as far as the B dash C dash value and with the BC, then I will write B dash C dash is equal to multiples of m is used for the multiple, and m into BC is to be there. Now in this case, the whatever be the value is taken. Now look at carefully, this BC is similar. If suppose here are the 2 points, if you look at this case, here I am writing this to be as in P and this is supposed to be as in Q. These 2 points are going to be formed. So BC is PQ having the similar, that means one translation is going to be here and this T is to be there. म्हणून BC आणि PQ हे जे मी कन्सिडर केलेले आहे म्हणजे त्याच इक्वल रेंजचे आहेत, म्हणून ते ट्रान्सलेशन तुम्हाला व्हॅल्यू देते, दॅट इज नथिंग बट टू बी टी इज टू बी देअर. म्हणून इथं टी लिहिलेलं आहे, या ठिकाणी तुम्हाला डायग्राममध्ये दिसेल, दॅट इज हिअर इट इज टू बी एज एन टी, त्याचा इथं आलेला आहे त्याच्यामुळे. सो हिअर दिस इज टी इज विथ दिस युअर पार्ट वेअर इट इज टू बी एज एन युअर PQ जे पॉईंट मी नवीन घेतले त्या संदर्भात ते आलेले 2 पर्टिक्युलरली हे ट्रान्सलेशन कॉमन आहे. आता उरला पार्ट मला समजा आता बी डॅश आणि पी I want to find out, and also I want to find out what exactly Q C dash is to be there. So to find out these values, you must have to know that is cos theta, how it is going to be calculated. So in this case, if you look at this, it is the way when the normal is drawn from the B to this P, that will give you the right angle triangle, and that will forms to be as an, you will find out the cos theta for in this case. So here again this P and your B is nothing but to be the translation, and if I am finding out B dash P in this case, and that will be nothing but to be having value T cos of theta. With the cos theta angle, if I found this particular value for the B dash P, that will become to be as an one single T cos theta. And similar way this will happen for this Q C dash is going to be there. So finding for the value for the Q C dash, that will be the value again another T cos of theta. And when I am adding this, all this I am talking about B dash C dash, if I add these all values, that will become to be as an 2T. Here for the B dash and P point, the distance or that particular line having the value T cos of theta, and for this Q C dash having the value another T cos theta. This one T cos theta for B dash P and another T cos theta for the Q C dash, that addition will give you 2T cos of theta. So directly it is not any magic or anything is to be there. This is what the 2T cos of theta value is coming there, and remaining what, this PQ factor, as the BC it is equivalent to the your BC, that's why this is your translation, and that's why I have taken it to be as an T. Now in this case, this is equal to multiples of BC. BC is nothing but to be one translation, and that's why it is written as a M capital T is to be there. So this is what the in the mathematical point of view, what the relationship for the B dash C dash and your original BC is going to be there. Now here again, if you do some trigonometric relationship simulations are to be simplifications are going to be there for this relation. If you look at this case where it is to be as an T, if I am putting it to be as an common, or in simple way, the T has a ह्या side लागेला, so it will become to be as an 2T and cos of theta, that will be particularly T cos of theta, or sorry 2T cos of theta is equal to it will give me basically M T minus T is to be there, and त्याच्यामधून जर T common काढला तर that will give me M minus 1 is to be there, so that will give me M minus 1. So this is what the M minus 1, and outside the T common is going to be there. मग इकडचा 2T cos of theta, the new relation will come 2T cos of theta is equal to T into M minus 1. So TT get, if suppose to be हा T पुन्हा इकडे right side ला गेला तर TT will get cancel, and you will get the new relation that is to be as an simply as an cos theta is equal to हा 2 जर पुन्हा इकडे गेला तर it will become to be as an divided. So cos theta value will become simply as an TT will get cancelled here from this, and the remaining value will be M minus 1 divided by 2 is to be there. I will repeat what exactly happening here. This TT is suppose going to be the common. जर समजा हे इथूनही कॉमन काढलं तर it will have 2 cos theta plus 1 is equal to MT. ह्या पद्धतीने पण करता येईल आपल्याला. So the T here and T here, if suppose from this T is going to the right side, then TT will get cancelled, only M will remain, and here the remaining part will be 2 cos of theta is going to be there. So in this case इथं जर काय लेफ्ट साइडला काय उरेल 2 cos of theta, this is what cos of theta plus 1 जो आहे तो इकडे गेला तर -1 होईल, म्हणजे तो बिकम 1 M minus 1 विल बी देअर, आणि हा cos of theta is equal to मग डायरेक्टली 2 हा राइट साइड ला गेला तर M minus 1 divided by 2 will be there. So in this way this relation will be found that cos theta is equal to M minus 1 divided by 2. So this is the value for that particular cos theta. Now why this all things are going to be there? We want to find out what type of the rotations are possible in such type of the symmetry. In this symmetry, what the symmetry I have done at this stage, in this symmetry either what type of the possibilities are there as far as rotation is going to be concerned. And now if you know for the cos of theta having the values, different values for this M, if M is an integer in this case, if I am putting the different values 1 2 3 likewise this, first of all you should have in your mind what will be the maximum cos theta value is to be there. Either cos theta, that is cos 0 is always maximum to be having 1, and if suppose the cos of that is to be as in cos are having the maximum value -1, that is to be in between these two range, that is -1 to 1. The whatever be the value for this cos theta, either the angle is moving from the 0 to 360, 0 पासून 360 डिग्री पर्यंत जर सगळे अँगल आपण मोजले तर cos थीटा मध्ये जर समजा ह्या व्हॅल्यूज ठेवल्या तर मला मॅक्सिमम व्हॅल्यू 1 पासून मिनिमम -1, मिनिमम म्हणता येत नाही पण रोटेशन फॉर्म्युला टॉप टू बॉटम इज टू बी नथिंग बट टू बी 1 to -1 ह्या रेंज मध्येच मला मिळणार. सो दिस cos थीटा इज हॅव्हिंग द व्हॅल्यू फ्रॉम 1 to -1. सो that is what the limitations for this cos theta, and here comes your part what the limitations for the folds of operations are to be there. Now in this case this cos theta is to be having this M is having to be the values. If suppose I am putting M here as an shown here, that is to be as an 3, in that case if suppose I am putting in this relation the 3 is to be there, M is equal to 3, जर 3 व्हॅल्यू इथं M ची जर ठेवली तर M minus 1, that is 3 minus 1, that will give me 2, 2 by 2 is going to be 1, and that's why cos theta will become 1. At that stage your cos theta value is nothing but to be, or the theta value is nothing but to be 0 in that case, because cos 0 is 1. So theta will become to be as in here 0 or 360, because it is the origin point from where your circle is going to be completing. At that time the your 0 or beginning, that is 360 end point, will be the similar, and that is what the having the value is going to be as an 0. That means force of operation 0 theta is going to be possible. Secondly, if I am putting for the 2 minus 1, that is 1 by 2, that is the theta value will be, that is 1 by 2. In that case, we know that theta will be becoming to be as a similar way. So these are the possible number of thetas I can find out with this case. When I am putting this 2 minus 1 1 by 2, that will give me the value for this, that is to be theta is nothing but to be becoming 60, 90, 120, 180. So in this case, there is no possibility for the theta as an 5 in that case. If I am forcefully putting that 5 inside it, the mathematically or physically it is not going to be satisfying your crystal lattice or the solid. So that's why this, therefore the transformation or folds of operations are possible only 1, 2, 3, 4 and 6 is going to be there. If I am doing this forcefully, in that case what will happen? See, this is what the mathematically we have seen, the 5 folds operations are not going to be possible, because if I am putting the m for the 5 minus 1, that will become 5 minus 1 will become to be as an 4 by 2, that means 2. And how it is possible? Cos theta never be the 2, and that's why this folds of operation is impossible. So this is what simple case, mathematical point of view, the 5 folds operations are not going to be possible in this case. So again, this is what mathematically, but physically what happens for this such type of the 5 folds or the 7 folds operations or the all type of the another operations, that wherever I am putting this value or putting this particular values and drawing such type of the crystal structure, in that case if you will find this is what the center point, in this case the diagrammatical form it is shown, that symmetry operations, if I am forcefully trying with the 5 folds of operation, you will find the structure, physical structure of that type of the crystal lattice will be like this. And if you look at this case, when I am rotation around the one point is to be there at the center of the point, you will find that there will be a gaps. This is what the white part is nothing but to be showing you gaps, and in the solid there is no such a type of the gaps are to be there as far as the solid or the crystal structure is going to be, completion is to be there. So such type of the physically or mathematically 5 folds or the 7 fold operations are not possible or do not covers the complete space, and in that case this such type of the 5 folds operations are absent in the as far as rotation symmetries are going to be concerned. And moving forward, that is what the in detail we have seen why this is to be the, and therefore we have seen that how many folds of operations are possible, that is only 5 folds of operations are possible, that is 1, 2, 3, 4 and 6 is going to be there. So now moving forward for the another symmetry operations, that is called to be as an reflection symmetry is going to be there. So now reflection symmetry is some sort of daily, when you are coming to the college, you are never missing the one thing, that is your mirror, because if you are hungry that doesn't matter, but you need a mirror while coming to the college, because you want to see how you looks, that how what is your reflection. And the same thing is going to be here, what exactly the reflection symmetry is, similarly in this fashion. So when I am using the such type of the reflection, when the symmetry is going to be there, if you look at the crystals or the diamonds you have seen, you will find the similar structure, reflection mirror images in the your crystals are to be there. And this is what exactly how it is going to be there, a plane in the lattice which divides it into 2 equal halves, or that looks like to be as in there each other to be as a mirror image. When we can see the twins, we can say they are both are mirror images to each other. That means mirror image, reflections of each other. That is what the we can say. When we are using the plane in the lattice, that shows you from that point half part or the remaining half part, equal half parts are going to be there, and both the half parts are equal in such a way that they looks like to be mirror of each other, and that is what it is nothing but to be called your reflection symmetries are to be there. And if you look at this here example is given you with the notch, the line of reflection symmetry is to be there, and m is representing to be as an your basically representing the plane or line also you can say. For this line I can also say it to be as an your plane, because plane passing through that case if it is cutting in that part. Now this is what the circle is going to be there, and the notch is going to be there. If you look at this is line or this plane, if forget this circle in a two half equal parts. If you look at this case here, if I am drawing this line or the plane through this way, you will see this particular case. I will draw it again. So if you look at this case where this notch is going to be there, if I am putting this line here, that will give me basically the two equal halves. If you look at this case carefully, it gives me the two equal halves that is going to be there, and that means if you look at these two halves separately, they are look like to be as an mirror images of each other, and this M is representing plane or line of symmetry, you can say. So this is what the simple case where the reflection symmetry's meaning is to be there. So how many types of the reflections we can see in your crystal structure? That is quite interesting. As far as the reflection symmetries are going to be concerned, both these reflection symmetries, that means to be as in rotation and reflection. Somehow the rotation and reflection symmetry are brotherhoods. They are related with each other, or they follow sometimes to each other. That is what the rotation axis associated sometimes with the reflection, and in this case the few of the reflections are with the rotation, and few of the reflections are without rotation. And this is what the case where the reflection symmetry is going to be found. So rotation axis is going to be associated with this reflection symmetry. That means this combination, there are some sort of possibilities of reflection symmetries. They are with your rotation axis, or some sort of reflections are without rotation axis. That is what the two cases. And as far as the rotation symmetries are going to be concerned, we know that rotation symmetries are of 5 types. So 5 rotation symmetries are also there, but with the combination rotation and reflection, both these are giving you, that means to be there are 5 allowed rotation axes are there, that we have seen 1, 2, 3, 4 and 6 is to be there. But possible number of combinations, if you will see, that will gives you the value for the reflection symmetry, that becomes to be as an 10 is going to be there. So now how many numbers of possibly to be here as in your symmetry, the reflection symmetries are going to be there. It is nothing but to be given to be as an here basically known to be as an 10 possible combinations are there. So in this case, if you look at here are the 1 m, 2 mm, 3 m and 4 mm, 6 mm are to be there. So here are the possible number of case where it is to be as an 10 number of possible combinations are there, and m here it is nothing but to be representing, first m representing the plane of the lattice along the axis or passing through the axis, and another m is representing the plane perpendicular to the rotation axis. One line or the one plane is first m is for the rotation or the line symmetry of axis, or the another is to be as an plane or line perpendicular to that rotation axis is to be there. So with this 10 possible number of point groups are going to be giving you the 2-dimensional point lattice are to be likewise this. So these are the 10 examples that are having the 1 m, and another is to be as an these are to be 1 m, that is 2 m, 2 mm, and 3 m, 4 mm, and here 6 and 6 mm's are going to be there. So if you look at this case where you are looking forward to be how this possible number of folds of operations part is going to be there. So this is somehow, if you draw this diagram for this particular case, it is to be as an if I am first m here 2 mm is possible, because if you do the one line, that is the plane passing through this case, it will give me the 2 equal halves, that is to be there. And if another m if I am drawing, that will be along this, it is also giving me 2 mirror images. That's why it is 2 mm is going to be possible. For every case, this is not going to be there. As far as another 1m is, if you will see, there is only one possible structure, or the one possible plane is going to be there in that particular 1m is to be there. Second, perpendicular m, that is to be the axis I can't draw, or the perpendicular to that axis I can't draw it, because it will not give the equal halves. So this is how these structures are going to be there as far as your two-dimensional point groups are to be there. So moving forward, the last one, that is